Okay, cyclic quadrilaterals means when we have a circle. Okay, this is our circle. In circle, when we connect 4 points, okay, 4 different points, those are located in the circumference of the circle. Okay, when we connect 4 different points. For an example, when I connect 1, 2, okay, 3 and 4. When I connect 4 different points in a circle and connected when it is giving you a closed shape. Okay, when we connect 4 different points located in the circumference of the circle and that will give you a closed shape. Okay, closed 4-sided shape. This is what we are called as cyclic quadrilaterals. Okay, this is the thing what is called as cyclic quadrilaterals. We can draw many kind of cyclic quadrilaterals in a circle circumference. Okay, for an example, when I connect like this. Okay, 1, 2, 3, 4. This is also a cyclic quadrilateral because the condition we need to satisfy while dealing with cyclic quadrilaterals, that is, all 4 points should be located in the circumference of this circle. That is your condition. Okay, all the 4 points which we are looking to construct the quadrilateral should be located in the circumference of the circle. Okay, circumference of the circle. Otherwise, that is not considered as our cyclic quadrilaterals. Here, we are totally dealing with two different theorems. Okay, two different theorems. First theorems says, okay, opposite angles. Okay, opposite angles in a quadrilateral. Okay, opposite angles in a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilateral are supplementary. Like means this is a cyclic quadrilateral. No? This purple color one. So in here, the opposite angles of a cyclic quadrilateral are supplementary angles. Supplementary angles mean this one is x, this one is y. Sum of these two, okay, sum of these two angles will give you 180. That is the term called as supplementary. Supplementary means when we add two angles. Two different angles, sum of two different angles give you 180. Those kind of angles are named as supplementary angles. Supplementary angles. Not this only. Okay, there are two more opposite angles. No, opposite angles in a quadrilateral. In a cyclic quadrilateral should be cyclic. Sorry, supplementary angles. Okay, for an example here, these are two opposite angles in a cyclic quadrilateral. Here I'll name it as A, this one as B. So sum of A and B will give you 180 again. 180 again. This is the first theorem what we need to study in cyclic quadrilaterals. What it says, I'll repeat once more. The opposite angles of a cyclic quadrilateral are supplementary angles. Okay, supplementary angles. That's the thing I indicated here. These are two opposite angles, so sum of them will give you 180. Similarly, these are two opposite angles in a cyclic quadrilateral. That one also will give you the sum as 180. Okay. Then in here, I'll give you a question. Let's try them. Okay, here, this is indicated as 110 degrees. Okay, 110 degrees. This is X. Okay, this one is X. And here I'll indicate this one as 45, not 45, 145 degrees. Okay, 145 degrees. This one as my Y. Okay, Y. These are different X and Y. Okay, I'll use M and M terms. M and this one is N. M and N. Okay, this one is N. This is M. Okay, let's try to identify the magnitude of M and N respectively. Okay, first thing, we have to check this is a cyclic quadrilateral or not. Okay, what are the conditions? All the points should be located in the circumference of this circle. Okay, that was satisfied. Then this should be a closed shape. Okay, this should be a closed shape. Okay, both of those conditions were satisfied. So here we can implement these theorems into this question. Okay, what it says? Opposite angles of a cyclic quadrilateral should be supplementary angles. So 110, its opposite angle that is M. Sum of them will give you 180 degrees. 180 degrees. To find the magnitude of M from 180, you should subtract this 110. So that will give you M as 70 degrees. M as 70 degrees. This is the thing you should know in this question. Okay, let's identify our magnitude of N here. Okay, this is a cyclic quadrilateral. So opposite angle sum is 180. Okay, its opposite angle 145. Opposite angle should be N. So 145 plus N is equals to 180. Okay, when you solve this, N should be equals to 180 minus 145. So N is equals to 35 degrees. Okay, this is the way you have to implement the cyclic quadrilateral theorem into questions to find the magnitude of a given angle. Okay, in this cyclic quadrilateral, all the 4 points are located in the circumference of the circle. No? So opposite angle sum should be supplementary angle. So 2y plus 1y. 2y plus y, that means 3y equals to 180. So y should be here. 180 divided by 3 will give you y as 60 degrees. This is the magnitude of y. Then for the next one, these two. Okay, these two. Sum of these two also 180. So 4x plus x means 5x equals to 180 degrees. 180 degrees. Then x should be equals to 180 divided by 5. That will give you 36 degrees. These are the magnitudes for x and y. X is 36 and y is 60. Okay, then let's take a look at our second question. Here M and A. We need to find for our M and A. For the M, this is a cyclic quadrilateral. No, hence it is a cyclic quadrilateral. The sum of these two will give you 180. So 150 plus M will give you 180. So M is equals to 30 degrees here. From 180, when you subtract 150, that will give you M as 150. Next one. Okay, that one is different one. Okay, sum of these two also will give you 180. Okay, let's take the sum. 3a minus 30 plus a plus 10. A plus 10. That is equals to 180. That is equals to 180 degrees. So 3a plus a will become 4a. Minus 30 plus 10 will become minus 20. Equals to 180. Then 4a equals to 180. Let's bring this negative 20 as a positive one. So 180 plus 20 will become 200 degrees. So A, 200 divided by 4. 200 degrees divided by 4, that will give you A as 50 degrees. Okay. We found our M as 30 degrees. That is a direct marked question. This is A is 50 degrees. Okay, for the next question, okay, here we have to use two theorems. First one is, okay, when we consider these 2 points, okay, these 2 points, when we connect them, okay, by using a construction line, when we connect them by, okay, connect them by using some construction lines, we can consider this line as a chord of this circle, okay, chord of this circle. This chord, okay, this chord is creating this angle in the center. This particular angle in the center. Okay, let's find that angle first. To find that, what do we need to do? This is a circle. Okay, this total angle covered by this point is 360. From 360, when you subtract 250, that will give you 110. Okay, this particular angle should be 110 here. This is 110. Okay, then the same chord is creating this particular angle in the circumference. By using a chord, one angle is created in the center and another angle created in the circumference. What is the relationship? The angle created in center is double of angle created in the circumference. Okay, in the circumference. So this should be half of 110. So R is 55. We can find our R as 55. Okay, R should be 55. Then let's find our X. Okay, X. Most of you did a small mistake. This is not a cyclic quadrilateral, no? This is not a cyclic quadrilateral. What is our conditions? What are our conditions to satisfy our cyclic quadrilateral? All the 4 points should be situated, okay, located in the circumference. Okay, these 3 points are situated in the circumference. What about this particular point? This is located in the center. So this is not a cyclic quadrilateral. If you thought like that, that's totally wrong. Okay, that's totally wrong. This is the way you should follow. Okay, this is the angle created by the chord in the center and angle created by the chord in the circumference. That should be half of 110. So R is 55. Then you can use this cyclic quadrilateral because all the 4 points are situated in the circumference of the circle. So we found our R as 55. So X should be 180 minus 55. 180 minus 55. That will give you your answer as 125 degrees. So, what is the magnitude of X here? That should be 125. Okay. Most of you did the same mistake. You considered this as a cyclic quadrilateral. That's wrong because this particular point is located in the center. Okay. Change that answer and correct that according to the correct answer.